Good day, class. Let us look at the system of connected bodies. We have three bodies that are connected over a frictionless pulley. Body 10 kg is resting on a flat surface. Body 5 kg is suspended, and 8 kg is also suspended. When you look at this system now, 8 kg is bigger than 5 kg. What happened is the 8 kg will be going down, it will be drawing 5 kg up. When you look at the tension in it, let us analyze 5 kg. 5 kg, it's going to be acting downward, while tension T2 will be pulling it up. Then it will be accelerating upward. Then for this 10 kg, tension T2 will be pulling it towards this side, while T1 will be pulling it towards this side. Then for body 8 kg, because it is going down, its weight will be pulling it down, the acceleration will be downward, while the tension will be pulling it upward. Now, it is our aim here to calculate the acceleration of the system, then the tension T1 and T2. Now, as usual, we are going to write equation of motion for all the three masses. Now, we know that the weight is equal to mg, which is equal to, this is 5 g in terms of acceleration due to gravity. That of this one is also mg, which will be 8 g in terms of acceleration due to gravity. Now let us write equation of motion. Equation of motion for 8 kg. When you look at it, because it is coming down, the weight is pulling it down, while the tension T1 is pulling it up. Since it is going down, that means the weight is higher than the tension. Then from here, the net force here, the net downward force is going to be the weight minus the tension. I will know that net force is equal to mass times acceleration. Then here, weight is equal to mg minus t, which t? T1 minus T1 is equal to the mass, which is 8a. Then here we now simplify this one further by making T1 the subject of the formula. We transfer T1 to this place. Okay, here what we are going to do here is the mass is 8 kg, it will be 8g in terms of acceleration due to gravity, minus T1 is equal to 8a. Then we make T1 the subject of the formula. We transfer it to this place. We have T1 is equal to 8g. We move this one to this place, minus 8a. We call this one equation 1. Now, let us write equation of motion. Equation of motion for 5 kg. Now, for the 5 kg, since it is going up, that means the tension T2 is higher than the weight. Then the net force here now is going to be T2 minus the weight, which is equal to ma. Then we have T2 minus the weight is the mass times g, acceleration due to gravity is equal to ma. Then T2 is going to be equal to, T minus m is 5, g in terms of g is equal to 5a. We make T2 the subject of the formula. We have T2 is equal to 5a plus 5g. Let us call this one equation 2. Then we now write the equation of motion for 10 kg. So equation of motion for 10 kg. Now you see the 10 kg is resting on a flat surface. This tension is T1 is pulling it this way and T2 is pulling it this way. Since it is moving in this direction, that means T1 is higher than T2. Then the net force here, the net force is going to be T1 minus T2, and net force is equal to ma. Then we have T1 minus T2 is equal to, the mass is 10, is equal to 10a. Then from here, let us substitute the value of T1 and T2 from equation 1 and 2. So substitute the value of T1 and T2 from equation 1 and 2. So in doing so, we are going to have 8g minus 8a minus, we open the bracket, this is 5g plus 5a, then is equal to 10a. Then when we simplify further, we are going to have 3g is equal to 23a. We are going to have 3g is equal to 23a. Then a is going to be 3g over 23. Then we substitute the value of g, which is 3 multiplied. Our g is taken to be 9.81 divides by 23. When we do so, this one will give us 1.28 meter per second square. Now we have gotten this. What next here now is to substitute the value of this a into equation 1 and 2 to get T1 and T2. Now let us look at that. So substituting a is equal to 1.28 into equation 1 and 2. And equation 1 says that T1 is equal to 8g minus 8a. This will be equal to 8 times g, which is 9.81, minus 8 times a, which is 1.28. When we evaluate this one, we are going to get 68.2 Newton. Then for equation 2, T2 is equal to 5g plus 5a, which is equal to 5 multiply 9.81 plus 5 multiply 1.28. When we evaluate this one, we are going to get 55.4 Newton. Thank you very much for listening.